Relationship between Q and K. Learning Objective 6.4. The student can, given a set of initial conditions, concentrations of partial pressures, and the equilibrium constant K, use the tendency of Q to approach K to predict and justify the prediction as to whether the reaction will proceed towards the products or the reactants as equilibrium is approached. Now I will be using cubes to demonstrate the relationship between Q and K. Here we are able to see science practice number 1. The student can use representations and models to communicate scientific phenomena and solve scientific problems. By knowing the relationship between Q and K, we are able to see if the reaction is at equilibrium, if it shifts to the reactants, or if it shifts to the products. With the first set of cubes, Q and K are equal size, so they're equal to each other, meaning they're at equilibrium. With the second set of cubes, the cube representing Q on the left is greater in size than the cube representing K on the right. Therefore, Q is greater than K, meaning the reaction will shift towards the reactants. And finally, for the last set of cubes, the cube representing Q on the left is smaller in size than the cube representing K on the right. Therefore, Q is less than K, meaning the reaction will shift to favor the products. Now that we know the relationship between Q and K, we can use this knowledge to solve a problem. CO plus 2H2 reacts to form CH3OH. A 1.00 liters reaction vessel contains 1.2 moles of CO, 1.5 moles of H2, and 2.0 moles of CH3OH. How will the total pressure change as the system approaches equilibrium at constant temperature? And Kc equals to 14.5. To solve this problem, we need to find the value of Q by putting products over reactants. When solving this problem, we must keep in mind that the concentrations of liquids and solids do not change, so they are excluded from the equation. However, in our example problem, all of the states are in gases, so they will all be included. We would have CH3OH over H2 squared times CO, which gives us 2.0 over 1.5 squared times 1.2. This equals to a value of 0.74. Now that we know that Q equals to 0.74 and K equals to 14.5, we know that they are not equal to each other, so the reaction is not at equilibrium. Instead, because 0.74 is less than 14.5, we know that Q is less than K. When solving this problem, we are using science practice number 2. The student can use mathematics appropriate. We can also look at the relationship between Q and K on a number line. From the previous problem, we know that Q was equal to 0.74 and K was equal to 14.5. When we look at a number line, we see that Q is to the left of K because it is smaller. When Q is less than K, there are more reactants than products. As a result, some of the reactants will become products, causing the reaction to shift to the right. Because Q wants to go towards equilibrium, Q will move to the right, or also known as the products in this problem. From the previous problem and a number line, we are able to use science practice number 5. The student can perform data analysis and evaluation of evidence. Thanks for watching.